Welcome to the final part in our series of videos on Alberta Science 9B4, Chemical Nomenclature. This is chemical reactions. This is a big one. You will be using this in every chemistry course you take for the rest of your life. So students will describe familiar chemical reactions and represent these reactions by using word equations and chemical formulas and by constructing models of reactants and products. That includes combustion, corrosion, and replacement reactions. So just to clarify, you do not have to explain the formation of polyatomic ions. A polyatomic ion is not one single element but multiple elements. Some chemicals with polyatomic ions may be introduced. For example, copper sulfate, zinc sulfate, sulfuric acid, these all use SO4. But at this level, you could treat SO4 as a single unit. It's one block that puts everything together. And as a second note, you don't have to balance reactants and products yourself. I ask my students to recognize whether it's balanced, but to actually balance them, that process is covered in grade 10 sciences. All right, so introduction to chemical reactions. Chemical reactions are everywhere in our daily lives, from the burning of fuel in cars to the rusting of metal, and even the reactions that happen inside of our bodies. Understanding chemical reactions helps us make sense of the world around us and prepares us for further study in science. In this section or video, we will explore some familiar types of chemical reactions, learn how to represent them using word equations and chemical formulas, and see how models can help us visualize what is happening at the molecular level. So a chemical reaction occurs when substances called reactants interact to form new substances called products. During a reaction, the atoms in the reactants rearrange to make new combinations. Chemical reactions can be described in several ways, using words, using chemical formulas, and by constructing models. Word equations. A word equation uses the names of the substances involved. For example, if carbon reacts with oxygen to form carbon dioxide, the word equation is carbon plus oxygen, and then the right arrow says we are producing carbon dioxide. Carbon and oxygen are the things that are reacting. We call them the reactants. They produce carbon dioxide. Carbon and oxygen are reactants because they go in. Carbon dioxide comes out. That's a product. Word equations are helpful because they are easy to understand and show what is happening in plain language. We don't see them a lot as we get further in courses because they do take up more space on the page and they leave out all the numbers that provide additional information. Chemical formulas use symbols to represent the elements and compounds involved. For example, carbon is represented as C, solid, oxygen is O2, gas, carbon dioxide as CO2, gas. The chemical equation for the reaction above, that carbon plus oxygen making carbon dioxide, that's written like this. Carbon solid plus oxygen gas. The right arrow says we are separating our reactants and our products. The product is CO2 gas. Chemical formulas are more precise and show the exact substances involved. Yes, carbon is exact, oxygen is exact, carbon dioxide is exact. In more complicated reactions, we need to know things like balancing charges, coefficients, and some of that is easier to get with the math. Plus, it just takes up a lot less space on the page. It's less to write. The models of reactants and products. Models can be physical, like ball and stick models. We talked about those with peas, with potato cubes. The toothpicks were our sticks. or you can use drawn diagrams to show how atoms are arranged before and after a reaction. These models help us visualize the changes that occur during a chemical reaction. So let's look at three common types of chemical reactions: combustion, corrosion, and replacement. Combustion is a reaction where a substance reacts with oxygen and releases energy, usually in the form of heat and light. A familiar example is the burning of carbon. The word equation is carbon plus oxygen produces carbon dioxide. The chemical equation: carbon plus oxygen produces carbon dioxide. In this reaction, carbon, which is often in coal or wood, combines with oxygen from the air to produce carbon dioxide gas. So combustion is burning, it's fire, it requires oxygen. Combustion reactions are important in everyday life, such as heating homes, cooking food, and powering vehicles. Corrosion is a reaction where the metals react with substances in their environment, often leading to damage. The most common example is rusting, where iron reacts with oxygen. It's not combustion. That has flames, it's very rapid, releases a lot of energy. Corrosion is much, much slower. The word equation is that iron plus oxygen produces iron 2 oxide. Notice we have that Roman numeral 2 to tell us something about the charge of iron because we have two options. The chemical equation is Fe solid plus O2 gas produces FeO solid. This is not fully balanced. Like I said, you don't have to balance it yourself. A balanced equation, the number of each type of atom on the left matches the number of that same type of atom on the right. Here the iron's balanced, there's one of each. The oxygens do not. We have two on the left and one on the right. So we should have 2's out in front of both iron and iron oxide to balance this one. Here, iron metal reacts with oxygen from the air to form iron 2 oxide, a compound that makes up rust. Corrosion can weaken structures and is a concern for bridges, cars, and other metal objects. Replacement reactions occur when one element replaces another in a compound. An example is when zinc reacts with copper 2 sulfate. The word equation is that zinc plus copper 2 sulfate produces zinc sulfate and copper. So the zinc has taken copper's place, bonded with the sulfate. The chemical equation, we have that Zn plus CuSO4 produces ZnSO4 and Cu. Notice that both of our sulfates, both compounds CuSO4 and ZnSO4, they're both aqueous. So someone has put solid zinc into a copper sulfate solution. The zinc dissolves, and the copper comes out as a solid, so that copper would appear as a precipitate. In this reaction, the zinc metal replaces the copper in copper 2 sulfate, forming zinc sulfate and copper metal. Replacement reactions are used in industry to extract metals and in batteries. This is a single replacement reaction. In a double replacement reaction, two elements trade places. Here's one example. The word equation, silver nitrate plus sodium chloride. Well, the silver and sodium are going to swap because the metal swaps with a metal, not with a nonmetal. That means the silver is now attached to the chloride, and the sodium is now attached to the nitrate. The chemical equation, AgNO3 plus NaCl, produces AgCl and NaNO3. Yes, this one is balanced. So polyatomic ions. Some compounds contain groups of atoms called polyatomic ions. Poly meaning many, like in polygons. For example, copper 2 sulfate and zinc sulfate both contain the sulfate ion. That's SO4 with a 2 negative charge. While you do not need to explain how these ions form at the grade 9 level, it's helpful to recognize when they are there. So you can look at all of those SO4s in the equation as one single unit. It's one block. You may also encounter sulfuric acid, the H2SO4, which is important in many industrial processes. So, for balancing chemical equations at this grade level, you are not required to balance chemical equations. You don't have to figure out what coefficients will keep the number of atoms the same. That's what balancing is. It means making sure the number of atoms in each element is the same on both sides of the equation. It's a lot of least common multiple stuff. This is a skill that you will learn in later science courses, such as Science 10. That's where you learn a lot of it, and you will be doing it constantly in Chemistry 20 and 30. So if you are interested in learning more about chemical reactions, you will have opportunities to study chemistry in greater depth in future science courses. Alberta's Science 10 is combined, so you'll have some bio, some physics, some chemistry, and some earth and atmospheric sciences in one course. Starting at the 20 level, you can pick and choose whether you keep going with combined versions or take dedicated chemistry, physics, biology courses. In those more advanced courses, you will learn how to balance equations, understand more complex reactions, and explore the behavior of polyatomic ions. In conclusion, understanding familiar chemical reactions, helps us make sense of everyday phenomena, from burning fuel to rusting metal and chemical changes in batteries. By representing reactions with word equations, chemical formulas, and models, we can better understand how substances interact and change. This knowledge lays the foundation for further study in chemistry and helps us appreciate the role of chemical reactions in our world. So check for understanding. Which of the following is a word equation for the reaction between hydrogen and oxygen to form water? Is it 2H2 plus O2 produces 2H2O? Is it 2H2O produces 2H2 plus O2? Is it hydrogen plus oxygen produces water? Or water produces hydrogen and oxygen? Pause now if you need more time. It is our third option. The first option is also correct in terms of representing the reaction, but we were specifically asked for a word equation and not the chemical equation. What is the chemical formula for the reaction of sodium with chlorine to form sodium chloride? So is it Na plus 2Cl makes NaCl2? Na2 plus 2Cl2 produces 2NaCl2? Is it 2Na plus Cl2 produces 2NaCl? And 2NaCl produces 2Na plus Cl2. Pause now if you need more time. Well, the question tells us we're starting with Na and with Cl2. Option 3 is the only one that actually has that starting point. Option 1 doesn't have Cl2, it has Cl. Option 2 has Na2. And option 4 has the reaction reversed. That's what we call a decomposition reaction. Which of the following represents the balanced chemical equation for the combustion of methane? You'll notice all four of them have methane, which is CH4, plus some number of oxygens produces carbon dioxide and water. Like I said, you don't have to figure out how to balance it. We're just counting to see if they're balanced. So which one has the same number of each element on both the left and the right? Pause now if you need more time. Option 1 has one carbon on the left and the right, one oxygen on each of the left and the right, 4 hydrogens on the left, but only 2 on the right. So the hydrogens do not balance. It is not option 1. Option 2 has the same hydrogen problem. 4 on the left, but only 2 on the right. 3 and 4 do balance our hydrogens. 4 on the left, 4 on the right. They also balance the carbons. 1 on the left, 1 on the right. So it's going to come down to the oxygen. It's multiple choice, so we might notice that the right-hand side is identical in both, CO2 plus 2H2O. We have 2 oxygens in the CO2. We have 2 in the water, because we have 1 per molecule and 2 molecules. That means we need the one that shows 4 oxygens on the left to match the 4 on the right. That is option 3. Option 4 does not balance because it has 6 oxygen on the left and 4 on the right. In a chemical reaction model, which of the following best represents the reactants in the reaction between hydrochloric acid and sodium hydroxide? So we have to remember which side of the equation the reactants are on. Are we looking at HCl plus H2O, HCl plus NaOH, H2O plus NaCl, or HCl plus H2O? Pause now if you need more time. They practically gave it to us in the question. Option 3 is actually the products. So HCl plus NaOH produces H2O plus NaCl. Which of the following is a correct model representation of the decomposition of water into hydrogen and oxygen gases? So we have H2O producing H2 plus O2. So H2O produces 2H2 plus O2. 2H2O produces H2 plus 2O2, or 2H2O produces 2H2 plus O2. All 4 of these have water becoming hydrogen and oxygen. They've got the right molecules. This comes down to balancing. Bullet point 1, the hydrogens balance, the oxygens do not. 1 on the left, 2 on the right. Option 2, neither balances. We have 2 hydrogen on the left, 4 on the right, 1 oxygen on the left, 2 on the right. Option 3, we have 4 hydrogen on the left and 2 on the right, 2 oxygen on the left and 4 on the right. That's not balanced. Option 4 has 4 hydrogens on both sides and 2 oxygens on both sides. This not only wraps up our look at topic 9b4, this would wrap up the entirety of Unit 9b, the chemistry unit in Alberta's Science 9. If you have any questions or feedback, please feel free to leave them in the comments here, and I will do my best to get back to them and respond in a timely fashion.